So I'm going to talk about predator-prey cycles. We've already looked at things that can affect population size, such as some abiotic factors, so they're non-living components of the ecosystem, like temperature, rainfall, sunlight, etc. We've looked at biotic factors that can affect population size, so competition, whether that's intra-specific competition between the same species, or interspecific competition. So if they occupy, especially if they occupy the same niche, they'll compete with each other for food sources, etc. They can affect population size. Another example of something that can affect population size, a biotic factor, is predators and prey, depending on whether you're the predator or the prey, and it creates what's known as a predator-prey cycle. A classic example is the lynx and the snowshoe hare. Please watch this video on this link to illustrate their relationship. And you get these peaks and troughs in the predator and prey. And we're going to go through how to answer questions on these. So here's a framework for how to tackle a longer question explaining a predator-prey cycle. And you have to include both describe and explain and quote figures, usually within mark points for this. So first of all, it might not be obvious to say so. State how long the cycle lasts. So what's the duration between peaks of a predator or prey? And then the prey will increase due to low numbers of predators. So if there's fewer predators about, the prey will increase. So you can quote some figures about when the prey will start to increase. There's then, as the prey increases, there's more food for predators, so the predators' numbers will increase. And the predator will peak after the prey, so you can quote the figures for when the peak of the predator was and when the peak of the prey was. And then because you've got more predators, you've got increased predation, so that's going to reduce the number of prey. And then a reduction in the number of prey will be lack of food for the predators, and again you can quote figures. We'll see an example on the next page. So here we've got the stoats and lemmings. So stoats the predator, lemmings the prey. There's a nice video to watch here. It's about rabbits and stoats, but it illustrates the point. So let's look at the framework and apply it to this question. So it's a 4-year cycle, and you can see that the difference between the peaks or the troughs is about 4 years. So if you look at the peak here, that would be in 1990. If you look in the peak here for lemmings there, that would be 1994. So 4 years. So first of all, and you can start anywhere within the cycle really, unless this directs you in the question. So I'm going to start that lemmings increased due to low numbers of stoats in 1993. So you can see here a trough in stoats, so very low numbers. You can see at that point the lemmings start to increase after that. That's because then as the lemmings start to increase, there's more foods for stoats, so they start to increase. And you can see that here, as they're increasing, later on the stoats will start to increase. The stoat peaks after the lemming, so the predator is peaking after the prey. So the peak in lemmings in 1994, and then after that you get a peak in stoats in 1995. You've then got, now here in the graph, you've got increased predation, and so you get a reduction in the number of lemmings. You can see earlier, so about here is when you start to get increased predation, and after that point you start to get a reduction in the number of prey, the lemmings. And then the number of stoats will then start to decrease due to lack of food or starvation, so that you can see the stoats start to decrease from 1995 to 1997. So as these start to decrease, that's followed by a decrease in the stoats. So if you use that framework, you should be able to get most marks on most questions.